Hello everyone, this is a video tutorial on running Kmeans clustering algorithm in Spark. Spark runs on the Hadoop platform and it accesses the data files that are scattered in the Hadoop distributed file system. Here we are using the Spark's machine learning libraries to implement the Kmeans clustering algorithm. Coming to the Kmeans clustering algorithm, it is a type of machine learning technique which is unsupervised, where you do not have a target variable that has to be predicted. This is not a classification problem. Kmeans clustering is one of the most widely used unsupervised machine learning technique. We will divide a data set into different clusters where each cluster will have data points which are very similar to each other. So what happens in Kmeans clustering is that we first select randomly a set of centroids, and depending on the similarity between the neighboring data points and the centroid, we will map these data points to the respective centroids. This happens on iterative basis, and after a set of iterations, we will see that the entire data set has been transformed into a set of different clusters where there is a lot of difference between different clusters but similarity between the points within the cluster. So let's get started. So here we have two data files, the segment challenge and the segment test. Both the data files have been stored in the .txt format. Segment challenge will be used to train the Kmeans clustering model, and segment test will be used for the model to perform the prediction on. Copied these two files on the Cloudera desktop, segment challenge.txt and segment test.txt. So we have to go to U, and in the file browser option under the Spark directory, I've created a folder called as input, and in this folder I have uploaded these two data files from the Cloudera desktop. So you can see here we have the txt formats of both the data sets. As you can see, this is the segment .challenge dataset on the file browser. So here in the Eclipse IDE, I have installed SCALA. You can do this by going to the help option here and then going to Eclipse Marketplace. This will open a dialog box where you can search SCALA IDE and then install SCALA IDE on the Eclipse. So here we have created the Kmeans project. This is a Maven project. So here in this you have the pom.xml. In pom.xml you can add the dependencies to it. So if you see pom.xml, here I've added the dependencies for Spark. It uses Spark Machine Library 2.10 and then Hadoop Common 2.6. This is basically to link the Spark and the Hadoop. So when you add these dependencies to the pom.xml, you have to save it. Once you save this, there will be jar files that will be created in the Maven dependencies directory. So these are the jar files that we are using. Here SCALA library container, we have selected the 2.10 bundle which has SCALA library reflect and swing jars. For the main and the test source folders, we have used refractor to change from Java to SCALA. So also under the Kmeans clustering package, we have added an SCALA object which points to the package, the Kmeans algo.scala. This will have the SCALA code which is required to read from the input data set, predict and run the algorithm and predict on it. So let's start with the code. We have made a package Kmeans, and in that we have defined the SCALA object Kmeans algo. So here we have the libraries that have been imported, Spark machine learning libraries, you can see here, and then we have the Spark context and the Spark conf. Now in Spark context is basically for a driver to access a cluster, and using Spark conf we can define the configurations for the Spark context. Then we have created a conf object for the Spark conf class, and we are passing training means through the setup name function and local through setmaster as we are running the program locally. Then we have an object SC for the Spark context class. As you can see, we are using this SC object here to read the text files, segment challenge.txt and segment test.txt. And then we are storing those in the training data and the predict data. Here in the training data, we'll first remove the headers and then we'll split them according to the delimiter, which is here comma. So this will be done for both the training and the predict. We'll split them based on the delimiter. This split train file, we are assigning them or mapping them to this CC1. This is basically the case class object. It's a functionality of SCALA. Here we define a set of attributes and these are immutable ones. So coming back, we are basically mapping the data set for which we have removed the headers to the case class objects. We are creating data frames from the RDDs for both the training and the test set. So data frame will organize the data set into rows and columns. Here what we do is we'll map the data frame to RDD with the data to train the K-means model. So we are basically training the K-means model here by taking the rows from the training data. Training data set vectors are created from these data frames and using the vector.dense function, and then we'll set the number of clusters to 3 and number of iterations to 20. So there will be 20 iterations on each cluster. The training vector that we created ahead is passed to the kmeans.train function, and this creates the K-means training set. We'll compute the cost. This is basically to print out the sum of square errors, and each cluster will begin with the cluster 0. We'll print these out as well. The training set will be in the Cloudera K-means output directory under trained model folder. The K-means model will be applied on the input data through the SC object, and then we will predict using the predict function and store it in the result RDD. The result RDD is then converted to a data frame using the data frame function, and thus the resultant data will be in a data frame format. So as you can see, we have successfully run the code. In the code, we had set the num clusters to 3. So in the output, you can see that there are 3 clusters which are enclosed by the square brackets. This is the first cluster, second and the third cluster. This is the sum of squared errors which is computed by the count function. Sum of squared error should be ideally very low. Then we have the final output. _1 indicates the position of the first element. Cluster numbers is assigned to every entry in the test data. For every row, we have a mapped cluster number. Also, if you check into the Cloudera desktop, in the home directory, we have the K-means output folder that has been created now. Inside that, we have the trained model, which has the data and the metadata folder. The metadata folder will have metadata about the trained model as well as the data that was given as an input to the model. Okay, so that's it for now. Thank you.